Diva, can you mute your mic? Diva san? Testing. Testing. Testing.
Now the sound is clear. Before there was a echo.
Okay. Right now it's clear, right?
Yes, doctor, it's clear.
Okay. Okay, Bismillahirrahmanirrahim. Alhamdulillah Rabbil Alamin. Wassalatu wassalamu ala ashrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri wa yassir li amri wa hlul 'uqdatam min lisani yafqahu qawli. Allahumma la sahla illa ma ja'altahu sahla wa anta taj'al idza shi'ta sahla. Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, and good morning. Alright, guys. Okay. Just information to all of you. Um, I will be no longer teaching you after this. Start on 1st January because I will do my industry attachment. Okay, so Dr. Aisha will again teach you and will continue the lecture until the end. Okay, so today and tomorrow is the last day. Tomorrow lah is the last day for me to teach you. So and okay, that is a simple information that I can share to you. All right, so let's move on to the lecture 10, which is a rectilinear part 2. Okay, what you will learn for today is the graphical method. We do have identity, the 7 graph. I still remember that one student mentioned in the class last week where we can calculate the area under graph to get the answer. Okay, so this time we will learn about it, the area under the graph to calculate the answer. Okay, under the mathematical identity and also graph profile later on. Okay, condition for v equal to 0, you already know about it. And the last one is of course the graph profile where we can calculate area under the graph to get the answer. And number 2, special case, maybe not today, but the special case will be covered on tomorrow, where the constant acceleration, we can utilize formula, utilize equation to get the answer. Okay, the equation is actually from physics that you have learned in the secondary school. We just utilize again the formula to calculate the displacement, the acceleration, and the velocity. Okay, and last one is example exercise. Okay, so this is the graphical interpretation method. Okay, actually this method is a simpler and direct approach when a motion of particle along a straight line experiences a few times. Okay, basically you only have to memorize the graph. Okay, no need to develop equation. Okay, if you are using graphical interpretation method, but again you have to make sure that you are very familiar with the graph pattern, with the graph trend. Otherwise you cannot get the same answer, the correct answer. Okay, but somehow this method is very simple, where of course as I mentioned to you, you no need to develop equation from the graph. Okay, if a graph given, then you can interpret the given graph into the new graph. Let's say the given graph is a ST graph. Then you can interpret the ST graph to become the VT graph. And later on, you can interpret the VT graph to become AT graph. Okay, this is the graphical interpretation. So if you want to use this, you have to memorize this 7 graph. Okay, we call it mathematics identity. The 7 graph. You can see there are 7 graph there. The first one, sorry. First one, second, number 3, 4, 5, 6, and 7. So we do have a 7 graph there. You can memorize. You have to memorize. Okay. So how to use this 7 graph is actually, it is coming, actually the initial graph, okay. The initial graph is coming from the problem, from the question. Okay. If the graph is given like number 2 here, okay. If you want to have the what we call it given graph here is displacement where ST graph number 2. Okay, so you can interpret ST graph to become a VT graph. So in order to get the VT graph, you have to integrate like you have to integrate the equation like the previous lecture. We do have integration. Okay, we do have integration. Okay. Testing. Guys, give me some minute. Some problem here. Okay, testing. Lagging, eh? Can you hear me right now? Okay, great. Maybe internet connection got problem. Okay, let's continue. Let's say the second graph given in the question is representing the ST graph, displacement times versus displacement versus time graph. So if this number 2 is given, if you want to have if you want to have the what do you call it VT graph, okay, what you should do actually, integration or differentiation. If you have a ST graph or S equation. Yes. Yeah, differentiation. Okay, differentiation. So if you have number 2 here, if you want to get the VT graph, you have to differentiate. Okay, you have to differentiate, and the differentiation will be occur. Okay, and you will get the second graph, which is the VT graph here, number 1. Okay, let's say the ST graph here, it is a linear graph here. So let's say S equal to what do you call it? For example, 10 lah. Okay. So if you want to get the V, you have to integrate this one. You will have V equal to 0 lah. Okay, like this. Okay. And maybe I can show you another example. Okay. Let's say the ST graph is here. Okay. ST graph is here. So if you want to have the VT graph, you can differentiate to get the VT graph here, like this pattern, okay? And this one is not using in your, calculation, in your in your solution. But again, if you want to have a AT, you have to differentiate. You will have this one, okay? This, the first graph here. Okay, so if I have the ST graph here, okay, you can get VT graph like this and AT graph like this. Okay, this will not need to be used. Okay. So if you have this line, okay, let's do another example here. Okay. So if you have the ST graph here, like this one, okay, then you want to get, sorry, not ST lah. I give example VT. Okay, VT. So if you have the VT graph here, okay, if you want to have the AT graph, you have to differentiate. Then you have to differentiate. Sorry, differentiate this way. Okay. And then you have integration to get the ST graph. Okay. So basically, what I want to show is you have to follow this arrow. Okay, this arrow. Okay, integration and also differentiation. So if differentiation is it coming from the below to the top, okay, and if integration is coming from the top to down, okay. So basically you have to memorize this. We have the linear one, okay, we have the 0 0, the 0 1. Normally I will remember like this. Zero graph which is no value at all, okay. This is the positive, this is the negative, linear, okay. This is linear, this is also linear one, okay, linear. This is positive, this is negative, this is the quadratic equation, okay, positive and negative. The positive negative values stand for, let's say for this one is let's say I put it y equal to 2 lah. Okay, this one y plus 2, sorry, y equal to 2x plus 0. This one is y equal to, oops, y equal to 2x2 plus 4, for example, plus 0. Okay, so if this negative sign should be y equal to negative 2, same, y equal to negative 2x plus 0, y equal to negative 2x square plus 4x. This one should be 4x. 4x, for example. Okay. So the left part is positive sign, the right part is negative sign. Okay. So this is the 7 graph. So if you want to have the area of the graph, this is the formula. Okay, this is the equation, two equation that normally we use to calculate the area and the graph to get the value. For example, you want to get the value of V or displacement. Okay, right. So if the given AT graph here, AT graph like this, for example, okay, AT, okay, the area under the graph, like let's say 0 until 2 here, is actually the value of V2 minus V1. Okay, area under the graph. Okay, area under the graph. So it is coming from, in my case, I put it 0 until 2 lah. TO, T1 is O, T2 is 2. Okay. So if given a t graph, you can get the value of v2 and v1 from the area under the graph. Okay, and let's see this, I erase it first. Let's say the graph is ET graph, like this one, for example, this one, VT graph. Oops, 0, 1, 2, for example. Okay, so you can get from VT graph, you can get the value of S2 and S1 where the value coming from the area under the graph. Okay, so this is the area. Okay, you can get this value, this area. Okay, oops, area equal to S2 minus S1. So same goes to this equation. Okay, so it is from T1 is 0, T2 is 2, like that. Okay, so you will get S2 minus S1. Okay, so normally the other displacement, either S2 or S1, will be given in the question. Okay, will be given in the question. So we will go further and we will see the example later on. Okay, so this is the area under the graph. All right, any questions so far? Any question? Okay, so far no. So I proceed to the next one. Okay, this is the special note. I think it is similar. Okay, like before, where the condition of v equal to 0. Okay, when v equal to 0, particles start to rise. Of course, the particle is not moving yet. It's going to move, but it tend to start. Okay, from the rise. Another condition where the v equal to 0, particle changes direction. Okay, when the vt curve or line crosses the t-axis. Okay, crosses the t-axis. For example, like this. Okay, vt, right? So the graph should be like this, for example. Okay, this one. So we do have t equal to 0 here. Sorry, not this one. Sorry, not t lah. V equal to 0. This one, v equal to 0. So there are two turning or stopping or starting point. Okay, give me some time. I have to put charger. I have to charge my laptop. Okay, so the example, particle changes direction when VT curve or line, okay, crosses the t-axis, like this example. And last one is a particle finally stop lah, of course. So stop. There are three conditions. You have to remember. Okay, why we need to have this condition? Of course, you have to have this condition to develop the equation, equation of displacement, velocity, and acceleration. So you will go through the example and exercise. Okay, the number 2 is graph profile. Okay, because the interpretation method, you have to know about this. Okay, the graph profile. You cannot simply draw the graph without the knowledge, the fundamental knowledge. Okay, so because if you do the conventional way, like the previous method, the previous lecture, you will know the equation directly. If the linear equation, you will get linear graph. If If the equation is quadratic equation, you will get quadratic graph. Okay, but graphical interpretation method, there is no equation that you will develop. Then you have to memorize graph profile in order to make sure that your graph is correct. Okay, number one, AT graph. So AT graph, lines between change in trend not necessarily connected. So mean actually like this. Okay, so you have the AT graph. Okay, line between change. Let's say I put the simple one. Okay, the constant value here. Okay, so from 0 until 2, for example. Okay, it can be like here 2, this one 1, and maybe a negative value -2. Okay, so what does this mean is actually the lines between changes. This line, this point, and this point is not necessarily connected. It can be separated as I show you right now. Okay, this connection and this connection not necessarily connected. Okay, so you will know that if you have this graph in your final question, in final answer, meaning that your graph is correct. Okay, because it is not necessary to be connected. Okay, all right, the second one is the VT graph. Lines between change in trend must be connected. So VT should be connected always. Should be connected always. Okay, the example VT. Okay, let's say the graph like this lah. Okay, from 0 until 1 here and until 2 here. Okay, and the next changes, let's say it is not negative more, it should be positive, for example. Okay, the graph, the next change will be connected, should be connected from here. Let's say like this. Okay, it should be connected. Okay, if the graph is not connected like this, let's say you got the final answer, for example, like this lah. It is starting from any point of V. Okay, but same T, any point of V, but like this situation. So your graph will not correct. This is wrong. Okay, this is wrong. So make sure that the line between changes in trend must be connected. Okay, must be connected. So if not connected, your graph is wrong. So another possible example is like this one. Okay, and should be connected, for example, like this one. And always connected when we have the changes at t equal to 2. Let's say this is t equal to 6. Okay, the connection is there. Okay, between the changes. Okay, the last one, lines between change, where the ST graph lines between change in trend usually smooth. So what does this mean? Is actually normally for the ST graph in the question we have the quadratic equation. Okay, quadratic equation like this one. Okay, the graph should be like this lah, for example, very smooth. Okay, it is somehow not very usually we can see the graph of ST is a linear pattern. It's constant value. It's linear pattern and also constant value. Normally ST graph, the line should be like quadratic equation. Follow the quadratic graph. Okay, and line VT changes. Let's say we have do different changes like this one. For example, let me erase. Okay, I have 2 points lah. Yes, 4. Okay, so let's say we start it here. Okay, should be smooth like this, for example. It is not necessary to be connected as well. Okay, it can be start from anywhere, like this position, for example, this one, and this time around maybe the graph like this. Okay. Okay. All right, this is the graph profile. Any question? Any question? Any question? No? Okay, if no, let's proceed to the next, which is, I think, example. Okay, so example, we will more understand when we go through the example. And of course, if you do a lot of exercise, then you will know, you will understand more. Okay, so this is the question. Okay, the question. Okay, the question is very simple. It is only in sentences. Okay, no graph, no equation. Okay, or maybe you can develop equation. Okay, but in this example, we will show you on how to develop the graph from the given information. Okay, from the example 6. Okay, so a particle moves with a constant velocity of 108 km per hour from A to B for a duration of t seconds. Okay, from A to B, we do have t second with the velocity of 108 km per hour. Then it decelerates constantly for 4 seconds from B to C. Okay, we do have a 3 point right now, A, B, C. The journey continues with a constant velocity of 54 km per hour. Okay, from C to D. Another point, which is D, for a duration of t seconds. If the total displacement from A to D is 2,880 meter, determine the TE, the time T, and the displacement from A to B. Okay, so you have to determine S in the end of the day, and also T, T and S. Okay, so T is this one, uh, and uh, and the one is T here. Okay, so you have to determine the T. Okay, how to do? Anyone? Any idea? What we should do first? Yes, draw the graph. What kind of graph is that? ST, VT, AT? The answer is VT. Okay, because the information here is velocity. You can draw ST. There is no information about ST from beginning until end. Okay, because the information about space is a total displacement. The information. So the information is the velocity from A to B. Okay. Another clue about the velocity from B to C. Okay. And the last one is C to D, the velocity as well. Okay. So you have to. Sorry, confused. Okay, never mind. Never mind, Alia, Sabrina. It is learning process. Bias jangan salah kemudian. Right. So let's continue. You have to draw lah. Okay. But I have to again memorize you, remind you. Okay, remind you where the unit here should be converted in the SI unit. Okay, unit here should be converted. Okay, should be changed converted in second. Okay, into the millimeter per second. Alhamdulillah. So anyone, how to convert? Do this. Okay, this the conversion one. Meter per second.
Multiply by 5 by 18.
Anyone?
Multiply by 5 by 18.
Mati. Sorry, cannot hear you. Hmm?
5 by 18.
So okay, thank you, Li Jiaying. The answer is correct. So it should be multiplied with 1,000 meter. Okay. Over our okay. 108 sorry, 30 per second. Okay. And then same goes to 54 kilometer per hour. You have to convert into the SI unit. 54 times with 1,000 over 3,600. Okay. You will get 15 meter per second. Okay. So this is your value from A to B. This is from A to B. This one from C to D. Okay. So from this information, you can draw the graph. Okay. You can draw the graph. Wait, okay, you can draw the graph. You can draw the VT graph. Lagging sekejap Alamak, internet lah problem. Right now, okay. Right now, okay. Okay. Yeah. Asan. Yeah, 5 over 18. Yeah, is same lah. Of course, you have to simplify. But again, I have to show the correct one, the original 1,000 over 3,600. Okay, it is same. It is same. It is same. Okay. Okay. VT graph. Draw VT graph like this. The axis first. Okay. V and T. Okay. And from B to E here, B to C here, B to D. You can put the alphabet first. Okay, you can put B, C, D. Okay. And then you can put the velocity from A to B, which is the constant velocity, 30 meter per second. Okay, from A to B here. Okay, and then it is decelerate constantly for 4 seconds. Okay, we know that this B to C is 4 seconds. Okay, A to B is T lah. Okay, and then decelerate meaning that the velocity is decreased from B to C like this. Okay, and then from C to D, the velocity is 54 kilometer per hour, which is 15, 15, right? So this one is 15. Okay, and this T is T second. It's not given yet. Okay, this is your VT graph. VT graph. Okay, all right. So from here, Okay, from here, you can get the value of T later on, okay, using the area under the graph. Okay, using the area under the graph. For example, for the AB, okay, for the AB, okay, this one, area under the graph. This area, as I mentioned to you, if the VT graph, the area should be S2 minus S1. Oops. Okay, area under the AB graph, graph for the AB period should be S2 minus S1. Okay, so area for this one is very straightforward, which is we have 30 times with T. Okay, 30, this one is 30, this one is T. Okay, 30 times with T. And S2, of course, the SB lah. Okay, because this one, SB, this point, SE, oops, this point, SC, and this point is SD. Again, lagging lagging the screen is lagging lah. Okay, S2, SB minus S1. S1 is SE. Okay, S1 is SE. So this is your first equation. Okay, but you can get the value of SB because SA is 0. Okay, at the beginning SA should be 0 if there is no information about the S when T equal to 0. Okay, if the S given, let's say the S given 10 in the question, you have to use S equal to 10 lah, to replace this one. Okay, you will get SB. But from this question, okay, T equal to 0, there is no S value when T equal to 0. So you can put S equal to 0 when T equal to 0. Okay. When S equal to 0, T equal to 0. When T equal to 0, S equal to 0. So there is no information about this. So you have to know about it. Okay, you have to aware about it. Okay, not all information is given. So you have to know. You have to understand. If the information is given, like I to you just now, when T equal to 0, okay, S equal to 10. So you have to use this one. Okay, you have to use this one. If no information about this, you S equal to 0 and T equal to 0. So you substitute S when T equal to 0 is S initial. Okay, so in this case, SA lah. So you can put SA equal to 0, then you will get SB, the equation for SB. This one. Okay. Sorry. Okay, the other one is, the other area is the BC, the period of BC. Okay, the period of BC, this one. Alamak, laptop ni slow dah pula. Okay, so BC, we do have two different kind of area, not different kind, it is trapezium lah, trapezium. So no, you already know the equation of area for the trapezium. Okay, so you can see BC like this one. Okay, so the area should be area under the graph. Oops, area BC, let's say I put BC lah. Oops, laptop ni. This one is area AB. Okay, so this is area BC. Okay, it should be SC minus SB lah. Okay, you should remember that S2 minus S1. Okay, so S2 in this case BC, the S2 is SC, the second point. S1 is the first point, which is SB. Okay, so ABC equal to SC minus SB. So A is the area for the trapezium. Okay, trapezium. Okay, this one. You should have the, let's say this A plus B lah. Time with height. Oops. Okay, and just I put the value here, the line here. Let me do something. Maybe this color. This A, this B, this I. Okay, this should be H equal to SC minus SP. Okay, so substitute all information there, you can get the SC. So since SB is there, SB is already calculated, already calculated there, you can substitute SB into the equation, you will get SC straightforward. Okay, the SC is value 90 plus 30 T. Oops, the answer is light in the screen. Aduh, laptop ni pun ujung-ujung macam ni. Okay, so you will get SC. Okay, SC. Okay, 9:56. Alamak, kena cepat ni. Okay, let me erase this thing. Okay, let me proceed. Let me do quickly. Not following my style. Just follow the slide here. Okay, for the CD, of course, CD, we have additional information there where AD is to 2,818 meters. So we can use this information to be put in the equation of CD. Okay, so again, CD, the area under the graph. Okay, very simple one. This one is 15. Okay, 15 times T. So the area is 15. This area. Okay, and of course, the displacement is SD minus SC. So we know that SD is the total displacement from A to D. You can substitute this value into the equation, you will get SC straightforward. Okay, SC straightforward. Okay. And then you substitute, sorry, this is from CD, ABC, sorry, BC. Okay, you substitute this information, CD equation into the BC, you will get this formula and the final T here. Okay, so this one is coming from the previous one. Okay, SC 90 plus 30T is coming from BC. And the CD is the, CD is SC. Let me do like this one. We do have 15T. SD2880 minus SC. Okay. Minus SC. So this is the first equation. The second equation, you can simplify the equation, you will get T in the end of the day. Okay. So this is the equation. You will get T equal to 62 seconds. Okay. And then you substitute T into the other equation, the first equation here. Okay, the first equation here. T equal to something, T equal to the value, you will get SB value. Okay. And then, okay, you will get this value. Okay. And then, that's it. That's it. This is the final answer. Okay, we already answered the displacement from A to B, which is SB. Okay, SB, and the T. Okay, the T is here. Okay, so this is the final answer. Okay, so this is a way. There is another way, which is you can analyze from A to D using, okay, you can get the graph of area. One, the second method is this one, area 2. Okay, you can put all together in a single calculation. Okay, area 1, area 2, area 3, and total SD is this one. As this one, DSD. So we know that SA is equal to 0, okay, where T equal to 0. So you substitute information here. Is SD, you will get straight answer like this, okay? So once you can get from A to B using the using this one. Okay, this one, SB. So you have two methods in this case. Okay, different case, different calculation. All right. So I think that's all. The time is already 10. I believe that you have a class after this. Okay. If you have any question, you can ask me right now. If you want to leave, you can leave for the next class. Thank you so very much. See you tomorrow. If you have any question, you can ask me right now. I will be waiting for you. If no question, you can leave.
Thank you, Doctor.
The attendant boleh kan? Because I forgot to mention about the class yesterday. Should be mentioned yesterday lah. So I will share the screen. Wait for the attendant Okay, let's see it. So, 3 left section. All right.